Trick AB, it's Ms. Deer here. I just wanted to, for those of you that are interested, talk about the method of cylindrical shells. It's kind of cool, it's not hard to understand, and it might be kind of fun to learn a new method. I'm going to use the example from your homework. So y equals 2x minus 4, y equals 0, x equals 11. So here I have x equals 11. I have the point 11, 22 minus 4, and my x-intercept of 2x minus 4 is 2, 0. So now that I have my graph, if I want to rotate this around the y-axis, so we can see that this is going to be hollow. It's not touching the y-axis. And if I were to make rings, my volume would be stacked in the y direction. So my volume would be pi r squared minus r squared in the y direction. My y values go from 0 to 18. My outer radius is constantly 11. My inner radius is constantly the function. If y equals 2x minus 4, x equals y plus 4 over 2. So that's what would go on the inside of here. So the method of cylindrical shells is really useful when you're rotating anything around an x equals where you would have to stack in the y direction because you don't actually have to switch your variables. So the idea here is we're going to stack cylinders inside of each other. And I always say that they're kind of like if you have a set of measuring cups at home, you have like the inner one, then the next one, the next one, the next one, and they sort of make a solid. But your each one is a cylinder. So the idea here is we're going to take a cylinder. So if I pick an arbitrary cylinder right here, right? So I'm going to have a little cylinder here. And the cylinders are getting both wider and they're getting taller as they stack. So the cylinders are stacking this way. And what's interesting is that if you think about it, if they're stacking inside each other this way, the cylinders are getting stacked in the x direction. So if I take my cylinder and I unroll it, it is now a rectangle. And the base of this rectangle is the circumference of the circle. So this is 2 pi r, and then the height of my rectangle is just my height. So if I look up here at my arbitrary cylinder, every point on here is x, comma, 2x minus 4. So as I move my cylinders out, my radius is always x, and my height is always my function. So my volume of these cylindrical shells would be, well, I'm going to stack the cylinders in the x direction. My x values go from 2 to 11. I want to stack infinitely many of these. So it's 2 pi r h. And because every cylinder by nature is hollow, you don't have to account for a difference whether it's solid or hollow. So let's do one more. If I want to I want to rotate around x equals 11. So this is pretty easy to do. It's going to go this way, right? It's going to be solid. So my rings would be the integral. Again, I'm going to stack them in the y direction, so the integral from 0 to 18 of pi r squared in the y direction. Now, because I'm rotating around x equals 11, my radius is not y plus 4 over 2, it's 11 minus y plus 4 over 2. I could also use cylindrical shells. And so if I were to do that, again, my cylinders are going to get stacked in the x direction. My x values always go from 2 to 11. That never changes. And I'm going to have 2 pi r h. Now my radius is going to be here, right? For any, I might need a new picture. I've killed this one. So if this is my shape, and I want to stack a cylinder. So my cylinders are tall and skinny, becoming shorter and fatter. If I pick an arbitrary cylinder, again, every point on here is x, 2x minus 4. But when I'm looking for my radius goes from x equals 11 to here. So my radius is not x anymore. It's 11 minus x, but my height is still just my y value. So if I look at this arbitrary cylinder, my height of my cylinder at the point x, 2x minus 4, my radius is 11 minus x, but my height is still 2x minus 4. These would give you the same numerical value, just a different way to do the same problem. So go ahead and you can check out this section in your book. There's kind of a different way to do them, and I can talk about them a little bit on Monday if you're interested. I hope you're having a great weekend.